Hello, folks. Welcome to another Levine Electronics and Electric webinar. We've done lots and lots of these over the past, I guess it's almost been a year. And thank you so much for attending and participating. We really built a nice sense of community here. It's wonderful that all you guys participate and ask questions and challenge us on certain things, and it generates a great and beneficial discussion. We are trying out a new format. We're continuing to evolve and try to make these webinars more productive and more entertaining. And instead of typing in your question, you're certainly always welcome to type in your question, especially if you don't like hearing your own voice. But we are trying out a new format in which you can raise your hand. There is a button for you to raise your hand, and at the end of the webinar, we will unmute your phone and you can ask your question and engage in some back and forth dialogue with the presenter if you would like to. And so today I'd like to introduce to you Adam Rens, and Adam Rens is with a company called Switchgear Power Systems that I've been involved with for a long time, and known Adam for about half that time. And this is a very interesting subject because Switchgear Power Systems has chosen to evolve and to reinvent and to progress towards more competitive and more functional solutions because of all of the work that is going on right now in the renewable segments like wind and solar. And so now I'm going to turn it over to Adam.
Yeah, thank you, Michael. And thanks to everybody for attending today. We really appreciate you giving us some of your valuable time to participate in this webinar. So before I get started, I'll give you a quick overview of what I'm going to present. So, Switchgear Power Systems, I've been here since 2012. I'm not sure how familiar everybody is with our company. So I will give an overview of, when we started and where we've been, where we are today, a little bit of information on the size of our company, where we're located, touch a little bit on some of the things that we value as a company, a little background on, in general, on the markets that we serve, the product lines that we offer, some information about those product lines, and then we will jump into some what we believe are unique 38 kV switchgear solutions that we can offer you and that you can offer your customers and clients. So SPS was founded in 2007, very small company at that time, 6 employees, located in a small facility in Oshkosh, Wisconsin, which is central Wisconsin. In 2010, the company relocated to the facility that you see in the picture. That is in Winneconne, Wisconsin, about 10 miles from Oshkosh, so still in the same general area. In 2012, the bright white roof that you see towards the top of the picture, that was the first expansion that we completed. It was 15,000 square feet. We hit 50 employees. That was the year I started at SPS. So I've been here a little over 8 years. And then a significant milestone in the development of our company was WBE certification in 2017. So we maintain that certification today. We were very fortunate to continue to have success and continue to grow. From 2018 into 2020, we hit 125 employees. This picture you see now is our current campus, includes these 4 buildings. We made the decision in 2018 to add our own sheet metal fabrication capabilities, which we had previously outsourced. So we kind of have a fabrication buildings, and then we have our assembly and main office with project management, sourcing, engineering, etc. And then at the same time, we added a high bay for our power distribution and e-house business with some overhead cranes and other equipment for material handling. So SPS values flexibility. So our flexibility is what kind of led us to introduce some of these unique 38 kV solutions in terms of the components and the designs that we offer. Also schedule. In today's environment, schedule seems to become an issue in a lot of different projects. So we always try and take a can-do approach in action. We know that we're going to be expected to adapt and react very quickly as things change in the project and whatever may come up. And then we really pride ourselves in being able to offer creative solutions to our customers to help them succeed and provide value to their customers. So the markets that we serve, utility, renewable is a big one. We do serve critical power and data center customers all the way down to industrial, a small amount of oil and gas and commercial, but it would primarily be industrial up to utility are the markets that we're serving. We are primarily a medium voltage manufacturer. We do build 480 volt equipment, but we are 95% medium voltage, which is one of the reasons that we are focused on the markets that we are. Everything from utility metering to power distribution centers, metal clad switchgear. So we do build metal clad switchgear. The focus of the webinar today will be on metal enclosed circuit breaker switchgear, which we believe is a good alternative to metal clad, but just want to make everybody aware that we aren't knocking metal clad. We do build metal clad switchgear. Metal clad, metal enclosed hybrid switchgear is what we refer to as gear that has a combination of switches and circuit breakers. So props to Michael. This picture right here was actually a project of Michael's where we integrated a main breaker with switch fuse for the feeders. This customer didn't place the value on circuit breaker protection on the feeders, so they saved themselves some money and went with fuses. Cat banks, we do build pad mount. Skid mounted equipment is applicable to a lot of renewable applications, being able to bring integrated equipment on a skid to site, put it down, interconnect it very quickly. And then bus duct and relay panels we do manufacture. So this is what we call a PDC. Some people call it an e-house or a PCR, and then an inside view of one. So I mentioned we do build metal clad switchgear, and from 5 to 38 kV, 5 kV and 15, we do 4,000 amp, well, a little lower amperage at the higher voltages, up to 63K, 15 kV. And we also do build 38 kV metal clad switchgear. So we believe that the metal enclosed circuit breakers is a great alternative to metal clad, but we recognize that not every customer, there are customers who do prefer metal clad switchgear with the draw breakers, and we do build that. Eaton, Siemens, and LS circuit breakers are who we offer. Rack out PTs at the higher voltage, and NEMA 1, NEMA 3R non-walk-in, and PDC construction. So the options that we offer for metal clad: arc mitigation, that is the fiber sensing and the relays, very common. I'm sure you're all aware of those solutions. Arc quenching is a solution we work on, and L3 is one of our reps who offers that, utilizing a Tech4 solution, same solution that we use. IR and ultrasound windows, and remote racking and integral racking is becoming more common for safety. So metal enclosed switchgear. This table is focused on what we would call more traditional metal enclosed with switches, sometimes switch breaker combinations, but same as metal clad, we build 5 to 38 kV. At 38 kV, we actually now offer up to 1200 amp load break. So switch fuse, switch breaker, I talked about. These two pictures here is a good example of what I will get into in more detail of a fixed mounted circuit breaker at 38 kV in a metal enclosed design. So you have provisions for utility metering, disconnect switch, and then you have your breaker feeding the circuit. And then you can see the single line here represents that. So it was a two-sided, two utility feeds, just a mirror image of each other. But that is an example. That was 38 kV of metal enclosed circuit breakers. So in our metal enclosed design for the switches, we offer air insulated switches and gas insulated. This slide is focused on the air insulated switches. I mentioned up to 38 kV 1200 amp load break switches. We do offer a third position switch for maintenance grounding. Very convenient for the maintenance personnel to utilize that rather than external ground cables, different operating handles. This unit right here, this was actually a 38 kV unit for a solar farm that we did a couple years ago, but a traditional metal enclosed switch fuse. So the flip side of the air insulated switch, we also offer a compact gas insulated switch. We utilize the Schneider switch mechanism for that. Same third position ground is available, sealed for life. That doesn't require arc rated PPE to do the switching. And like I mentioned, very compact footprint. Okay, so metal enclosed circuit breaker ratings. We're focused on 38 kV today, but we do apply the same principles to 515 and 27 kV. But at this particular voltage, we offer up to 3000 amp, 1200 amp and 2000 amp also, and up to 31.5 kA. So we believe that 38 kV switchgear utilizing circuit breakers, fixed mount in particular, is a good alternative to both metal clad switchgear and open air substation construction. So we utilize a fixed mounted circuit breaker up to 3000 amps. We utilize an EMA breaker, which is what is pictured here. And we also offer an ABB circuit breaker option. Load break switches up to 1200 amp, and that is how we provide visible break. Obviously, with the breaker not being draw out, there needs to be another means of visible break. And we do offer up to 3000 amp for non-load break switches. And even on a load break switch, a typical switching operation would not be done under load. You would use the circuit breaker. You would open the circuit breaker prior to opening the switch. And then we incorporate the station service transformer, any instrument transformers that you need, as well as protection and control, obviously. So the first area we believe it can be applied is as an alternative to open air substations. So the concept is we are able to take what would be the entire low side, the 38 kV side of the substation, and incorporate it into switchgear. And I've touched on a couple of them, but it includes the metering, switches that you would have in the substation, surge arresters, obviously relays and controls, batteries. So in many markets, when you talk about going out to places like California and other places, finding enough labor for the site can be an issue, and it can also be very expensive for contractors to have labor in those areas to do on-site work. So by utilizing switchgear, many times you can significantly reduce the site labor and also the commissioning time on site because the switchgear and all the components are integrated at the factory. It can be tested thoroughly prior to shipment. And we believe another benefit of utilizing switchgear is condensing all of those what can be separate purchase orders and logistics of buying switches from a vendor, maybe buying the instrument transformers from another vendor, the breakers from another vendor, into a single point of contact. The project management, engineering, logistics, and even some of the major manufacturers who maybe can provide a full spectrum of products. Many times they're coming from different plants in different areas of the country, and it's not all coming out of the same plant. So this is an example of a data center single line, and the hash marks on the breakers are actually not correct. That was, I don't know why those are on there. But anyways, this was the single line provided to us. And this is a customer of ours. We have the purchase order to do the engineering for this project, but this customer placed a large value on utilizing switchgear rather than building the substation open air, which historically is what they would have done. So outside of this revenue meter, which is supplied turnkey by the utility, they go underground from the metering, and the rest of what you see in the single line will be incorporated into our switchgear. So main disconnect switch of 2000 amps, and then the disconnect switches on both sides of each circuit breaker. We'll also be supplying the voltage transformers, current transformers, obviously, surge arresters. And so this is the switchgear layout that we are providing. So if I go back to the single line, you have your two breakers on each side, and then the incoming disconnect switch. So that is what you're seeing here, two breakers, incoming disconnect switch. So we're actually able to integrate the line and load disconnects for the breaker into the same section. And then one thing I will get into in a couple slides is the hybrid nature of this design, in that it includes non-walk-in switchgear and also an integrated control house in the same lineup. And that's why you see the HVAC right there. So this is a top view of that substation. So it's a 69 kV primary, and you can see that they come off of the transformer. There is the utility metering, and then underground feeding the switchgear. Underground feeding the switchgear. It could be some of our customers prefer to keep everything overhead, and in which case we would supply roof bushings to connect the same way you would connect to an outdoor station breaker. So for contractors who are used to coming off of the transformer right into roof bushings, into circuit breakers, we can provide that same functionality with our switchgear. But this kind of gives you an idea of eliminating a lot of the steel structures and poles that you would typically have for an outdoor open air design on the secondary side. So the second alternative, a place to apply this concept is as an alternative to metal clad switchgear. So you get the same circuit protection and switchgear controls that maintenance personnel that are used to metal clad switchgear, the same controls that they're used to. It is reduced depth and the fixed mount circuit breaker. So if you're specifying the gear to be in a PDC building, the depth of the switchgear is reduced, and also the circuit breakers being fixed mount allow you to shrink the width of the aisle, which brings the total building width down to a point where we can ship it in one piece and avoid shipping splits and reconnecting at site. As I mentioned before, the visible brake that you would normally get from the draw breaker is provided via group operated switches. And then we believe fixed mounted circuit breakers provide an advantage of not having to do maintenance on the racking mechanism. So anybody who has been around or experienced metal clad switchgear understands that the circuit breaker racking mechanism is a very mechanically complex device, requires maintenance, can break down. It's one of the most common failure points on a switchgear unit. So having a fixed mounted breaker eliminates those potential points of failure. So here is a wind farm single line for a project that we built last year. And this is what was specified initially. So it is draw out metal clad switchgear, the station service transformer, and some other protection ITs. So it came out specified as draw out metal clad switchgear. And we bid at draw out because, as I mentioned, we know that not all of our customers want fixed mounted metal enclosed. Some of them still prefer draw out. And this was the footprint that we developed for the metal clad design. So your switchgear was about 11 feet deep. And because the breakers are draw out, you need a large aisle. 38 kV breakers are obviously quite large. And the overall footprint of the switchgear was 21 feet, or of the PDC was 21 feet, I'm sorry. So because it was 40 by 21, it required us to have multiple shipping splits, and the PDC would have shipped to site in multiple pieces. So this is the metal enclosed single line that we proposed to them as an alternative. And it included an incoming main switch of at 2000 amps, and then your main circuit breaker, 2000 amps, and then 3 feeder breakers, one of which was a spare. Each feeder breaker had a 600 amp switch incorporated with it. In this case, they were low break because of the amperage. The main switch was a non-load break switch. So we gave them the visible break, and the footprint that we came up with. So the switchgear does get a little bit wider, and that is driven by the switches being incorporated with the breaker. But the depth of the switchgear went from 11 feet down to just over 8 feet. So that in and of itself would have reduced the width of the E-house from 21 to 18 feet. But they got the added benefit of reducing the walk-in aisle width, which brought the total width down to 14 feet. And so we shipped this building to site in one piece. One advantage of doing the PDC construction was they also incorporated the relay panels for the entire substation in our PDC, and we built those. They have their batteries and a panel for the turbines. So it turned out to be a very nice design, and we actually were able to offer our customer, about a 12% savings overall on the entire switchgear PDC package compared to the metal clad option. So that was just their upfront cost to us. And then it would have saved them any amount of time that they would have spent at site reconnecting the PDC and reconnecting any wiring that had to be unterminated for shipment. So this is some pictures of the gear that I just showed the top view of the PDC for. So you can see the bus is insulated just like metal clad switchgear. Here's the 2000 amp incoming switch. This was the termination section, so terminating, coming through the bus through the switch. And then for the feeder breakers, it's the same terminations that you would expect in metal clad switchgear. So it looks and feels the same in terms of how you're going to terminate to the cables. You're able to provide the same the CTs that the cables are able to come up through when they terminate. Here's just a more close-up view of the switches. We put viewing windows obviously in the doors, so you're able to verify switch position without opening the doors. And then here is a close-up view of the circuit breaker compartment. So yes, the breakers are not draw out, but they are easy to access. And in the event you did have to remove one for any reason, it is not impossible. It would take you longer than drawing a breaker out, obviously, but it's not something you couldn't get done in a day. So a specific application for the switchgear utilizing the fixed mounted breakers is for wind applications. So if you look at this picture, you see that there's two sets of vacuum bottles. So those are mechanically interlocked, and one of them is a high-speed ground switch. So when you talk about wind farm designs, traditionally you use either a outdoor station breaker or metal clad breaker in combination with grounding transformers. This circuit breaker allows you to not use grounding transformers, and the ground switch closes within 16 milliseconds of the main bottle's opening, and the same switches we provide for visible break. And so if anybody is familiar with EMA, their outdoor station breakers that they supply on wind farms, I know they've got a large market share of wind farms. We utilize their circuit breaker. It's the exact same breaker. It's just that we package it in switchgear versus they supply it in their outdoor station breakers. Hybrid outdoor non-walk-in switchgear. So I mentioned this in the slide where I showed the data center outline drawing. This is what it looks like as a picture. So we're giving our customers the benefit of having a walk-in climate-controlled control room without having to enclose the switchgear. So it's a good solution for a customer who maybe doesn't want to spend the money to buy a full PDC or e-house, but does have a need for some sort of control house where maybe they need batteries, maybe they need a couple of relay panels, maybe they need some control panels, whatever they might need can go in the walk-in part of the switchgear, and then the breakers and switches are non-walk-in. I mentioned roof bushings earlier, so this is obviously an example of that, where this customer is able to come right off the secondary of their transformer in the substation and connect right to the spade connectors, and they connect down into the switchgear. So it's a very clean design and easy design to implement in the substation. In terms of quality assurance, many of the same tests that we would perform on draw metal clad switchgear, we're obviously going to verify instrument transformer ratios and polarities, go through the relay schemes. We also have a full indoor rain test booth, so all of our outdoor equipment is rain tested prior to shipment, and we are ISO 9001 compliant. So with that, I would open it up to feedback, questions, any comments that anybody has.
So there's a button, should be on your controller, maybe lower left-hand corner, where you can press the button and raise your hand. And then we will unmute your phone. Otherwise, just type in your question and we will be happy to answer it. Oh, here's a question. Are you also ISO 14001 certified?
We are not ISO 14001 certified. It is something that's in our company roadmap, I would say. But we are not currently ISO 14001 certified, no.
Okay, here's a question from Kevin Tang. Kevin, your phone is now unmuted.
Yeah, my question is, your metal enclosed switchgear is saying like UL listed or UL certified?
Not UL, but we provide CSA US labeling. So we provide NRTL labeling, but it is CSA US, not UL.
CSA, okay.
And we
Okay.
provide the
Thank
38.
you.
Yep.
Okay.
Does that conclude your question, Kevin?
Yeah, because some of our projects, we've been asked to have either UL or minimum CSA certified or tested, so yeah.
Yeah, I've been involved in a couple projects with switchgear power systems where that became an issue, but it was easily resolved. There are some laws in place that I don't want to say force the AHJ, but it becomes very, very difficult for any AHJ to turn down a piece of switchgear that is listed with any third-party label. So we preach that that all three listing agencies are equivalent, that being UL, CSA, US, and ETL.
Yep, that is correct.
I do have another question. You mentioned the metal enclosed was your house option in comparison with metal clad 38 kV. You said that would be the saving, right? Because if you're doing the metal enclosed, you mentioned a 12% saving.
Yes. Yeah, so let me go back to that. So we bid them the project utilizing metal clad switchgear.
Mm-hmm.
And we offered them a voluntary alternate to go to this metal enclosed circuit breaker design.
Mm-hmm.
And the deduct to go to the metal enclosed design was 12%. So it was a significant, I don't remember exactly offhand, but it was from 1.1 something million down to less than $1 million for the total cost of the switchgear in e-house.
Oh, you mean for this skin with metal enclosed skin with one incoming 3 feeders?
Yes.
Oh, okay. Yeah,
So for
that
this
looks good.
particular project, it was about 12%.
Okay, very good. Because what happened, we recently have quite a few projects we send out, but of course, I mean, that's why been sent out, came back, it gave us the metal clad outdoor layout option. Right, that's just like this. The one incoming 223 feeders.
Yep.
Yeah, that's over $1 million a piece just for the NEMA 3R metal clad.
Yep. Yeah, the metal clad at 38 kV gets very expensive. The breakers are very expensive. All the components are very expensive. And yeah, for something like that, we would love to be able to offer an alternative utilizing fixed mounted breakers and switches because at the end of the day, a lot of customers, they just want the breaker protection. They're not necessarily hung up on the breakers being draw out as long as you give them some sort of visible break.
So my follow-up question will be, except the draw out or non-draw out, what will be the other cons for the metal enclosed option compared to metal clad?
What would be the other cons?
Yeah, that would be other drawback, for instance.
Well, we can epoxy coat and insulate the bus, which we do as a standard on this circuit breaker switchgear. The requirement to shroud all of the bus bars isn't there, and with the switches, it becomes more difficult to shroud the different potentials. But other than that, we think it's a great solution. I can't think of really anything off the top of my head that would be another drawback.
Okay. Is that possible? Excuse me. Is that possible? We can talk. Maybe you can. After meeting, you can give some details on this scheme.
Yeah, Kevin, we can set up a call with you and Mark Street.
Okay. So, oh, really? Good. Okay.
Yeah, I'll work that out with you.
Yeah, that would be great because that's what I'm trying to say. That's really is a good option to what we can have for all those metal clad, NEMA 3R with this e-house option because you for the saving, and with the e-house obviously is much better for all those other the battery system, the relay panel, all of that. Yeah, that would be much better.
Yeah, and so if there's cost concerns, so a substation that has, maybe an incoming breaker and 3 feeders, I don't know exactly how big it is, but you might consider utilizing the hybrid design where you could put the batteries and relay panels you need in the control room, integrated right in the non-walk-in switchgear, and that could possibly save you having to buy a separate control house from somebody like a Tracti.
Well, what we did on that, the switchgear vendor add another section of the lineup, just in housing the battery, system.
Oh, yeah. Yep. Yeah,
that's what they did. Another lineup to the metal clad.
Yep. Yeah, which we can do that as well.
Michael, you got a couple questions that came in typed.
Oh, thank you. I didn't see them.
Yeah, they were hidden probably. Go ahead.
Could you have incorporated the same footprint and offered a line side disconnect switch as well?
A line side disconnect on the breakers. The answer is the footprint to have a line side disconnect, it would get a little bit deeper than the 98 inches. So in order to have 2 disconnects in the per breaker, which would be what this design was. This is 2 disconnects, and it went to 140 inches. Part of that was, I believe, driven by the size of the control room that they needed. So we front and rear aligned everything. But yeah, this is this gear right here is what they'd be talking about with a line and load disconnect on the circuit breaker. Line and load. So definitely.
But metal clad, there's no, there will be no way to have those 2 disconnect switch incorporated. Is that right?
Correct. Not on metal clad. It has to be. It's a metal enclosed design. You're correct.
Okay.
Yeah.
One of the pros of this design, in my mind, and I've been around switchgear for a long time, and one thing I know is I think it's above 90%. It might be 91 or 92% of all part faults that have consequences to personnel occur during the breaker racking process.
Correct.
And I like this design because you use the load break switch to isolate that breaker, and you're not relying on a breaker racking mechanism.
Correct. Yep. That's a good point.
Cooper, did we answer your question? I can unmute you if you want to ask a question.
Well, there's one more question here. This is going to be tough for you to answer, Adam, but I can try to help you. What kind of cost difference would there be between Switchgear Power Systems gear with the non-draw out breakers versus, say, Powell metal clad gear with the integrated racking solution?
With the integrated racking solution? Yeah, I can't comment specifically to Powell. I know that many times the integral racking, it is definitely a cost adder compared to not having it. And I don't know what the premium is that Powell charges for that. But like I said, we have, in the projects that we've compared our metal clad to the metal enclosed design, it has ranged anywhere from about a 10 to 25% savings, depending on different factors. So comparing it to our own metal clad, and I mean, I don't believe that we're uncompetitive on the metal clad. So I can tell you that it is about 10 to 25% when we've compared the two. And we are fortunate to have a good relationship with a large general contractor who builds a lot of substations, and they actually we gave them some pricing on this design, and they gave us feedback on how it compares to when they build open air substations. And the feedback that they gave us was that on an upfront cost basis, it was about the same costs. And so when they considered site labor and commissioning time and things like that, the total installed cost was a savings for them, or would be a savings for them. Hopefully that answers your question.
Let's see. Kevin, did you have another question?
What is the your example that you house the metal enclosed? Could you go back to that slide? Yeah, no, not this one. Yes, this one.
Okay.
One
yep.
is, yeah, no, can you go back? go back to that e-house layout.
Okay.
No, that's right.
I think it's a couple slides. The e-house layout was.
So what is you said that yes, you said there's about 12% saving. What is the short circuit rating on those metal enclosed switchgear? Is 31.5 or is it 12 or 25 Ka?
I believe this one was 31.5 Ka.
Okay. So with the one incoming 3 feeder, okay, yeah, this looks good. Okay. So John, are you going to give us some details on this alternative? So you said that you talked to Mark.
Yeah, we can talk to you about it, Kevin.
Yes, I really appreciate it. You can call me back. I will definitely talk to our guy, including Mark. Yeah,
Okay, sure.
Yeah, this looks very. Because what happened? We started to purchase all those 34.5 kV. We end up from Powell metal card, because that's the only way. That's the only things they offer, So they don't have any things like metal enclosed.
Great. I'll set up the call. Thanks, Kevin.
Thank you.
I think that's it for the questions. Thank you so much, everyone, for your participation. And Adam, great job as always. And kudos to Switchgear Power Systems for coming up with some designs that are creative. Hope everyone has a wonderful day. I hope to see you next time.
All right. Thanks, Michael, for setting this up. Thanks, everyone.
Thanks, Adam. Great job.